Hey grade 9 top class, today is Friday, March 31st. I am away today at Regi for the Senior Math League competition. So you are watching these videos in class. Today you're going to be doing the Q of the D in random groups. So that means my peer tutors in my first period class are going to be putting students into groups of 3, and then students will be going to the whiteboards and working on this Q of the D question. In my fourth period class, please just go to a whiteboard, grab a whiteboard marker, and start working on the question in your small groups there. Right after that, we are going to be looking at Unit 3, Day 5, and our unit test is going to be after Easter. Alright, at any time within the video, please press pause, rewind, fast forward, and walk around the classroom to ensure that students are writing down the appropriate questions in their papers. If you're looking for more Day 4 or Day 5 questions or papers, they are on the right hand side of the teacher's desk and should be there. Alright. So go put students in, press pause, put students on groups, and let's get started on this EQAO question. So this is a question. Given 3 circles in a row that are not overlapping with no space in between them, each circle has a circumference of 20 centimeters. What is the length of all 3 circles in a row? So draw it out, try it out, work with your groups. If you don't know, go look at somebody else's group and work on this question. Please press pause and get students to work on it. Once they're done, you can get going with the Day 5. So give them about 10 minutes to work on this. Alright, so we're going to take up the question. So students should all have tried this question and hopefully gotten something completed. So the first thing we're going to do is draw all 3 circles in a row without, see, that's not what it's asking. It's all 3 circles that are just touching but no overlapping. All the circles in a row are 20 centimeters each for a circumference. Do you have any formulas that have circumference in them? Yes, you do. Circumference is equal to pi times diameter. So that means if circumference is 20, we can put 20 in for here and do pi times d. And we want to find the diameter in order to get all 3 of them together, and the length of all 3 of them, divide by pi, divide by pi. This is going to give us the diameter of one of the circles. So here we get 6.4. So that means this circle is 6.4, this circle has a diameter of 6.4, and this circle has a diameter of 6.4. And we add them all up together. Well, what do we get? We get 19.2. So our final answer is 19.2 centimeters. Alright, so hopefully you had something like that down, and we are going to go get started on Day 5. So please ensure that everyone has a pencil, something to write with, and Day 5 in front of them. Okay, so the volume. Volume is the area of the base times the height. Okay, so area of any base times the height. Here we're looking at the volume is measured in cubic units. So some examples are centimeters cubed, millimeters cubed, kilometers cubed. There's so many different ones. Again, please press pause at any time within the video so that you can slow it down and make sure students are writing down the work. To calculate the volume of the rectangular prism, we're going to do the area of the base times the height. So looking at the shape right here, the base is here. The base could be here or here too. They're both triangles, so that's fine because it's rectangles. Both of them are it's called a rectangular prism, so it doesn't really matter which one's the base here. If it's a triangular prism, the base is a triangle. Rectangular prism, the base is a rectangle. Cylinder and the other ones have special names. Okay, so the base here, we can see that the area is length times width, and then we're going to times the height. So the volume is equal to LWH. And you can find that right on your gold sheet as well. So you have your gold sheet, which has a regular rectangular base prism. The volume here is the area of the base times the height, which is LWH. All right, so let's determine the volume of the rectangular prism with a height of 2 centimeters, length of 5 centimeters, and width of 3 centimeters. So step 1, let's write down our steps. These are same steps from yesterday. Find the shape. So go and find it. Step 2, write down the formula. Step 3 is to sub in values. And step 4 is to solve with units. All right, so we went and found the shape already. The volume is LWH. The length here is 5, so let's put 5 in for length. We talked about yesterday using brackets to help us when we sub in values. W is 3 and H is 2. So let's solve this. Here we get 15 times 2, which gives us 30 centimeters squared? No, cubed. Okay, so therefore the volume is centimeters cubed. 30 centimeters cubed. Here we have a rectangular prism with a width of 7 and a length of 15 and has a volume. All right, so if our length is 15 and our width is 7, it looks like we're missing the height. Okay, so again, go find the shape. Again, a rectangular prism, so V is equal to LWH. Let's sub in these values now. Well, we do know what the length is. The length is L, which is 15. We do know what the width is. The width is W, which is 7. And we don't know what the height is, so we're just going to leave that as an H. Well, let's go put these ones in brackets. Do we know anything else? Yeah, we know that the volume is 420. So we're going to put 420 here. And let's collect some like terms here. So these can be multiplied together because they're the same. Those are coefficients in front of the H, so we can multiply those together. Now we don't want 105 H's, we only want 1 H. So we're going to divide it by 105. And we get those reduced to get 4. So therefore the height is 4 centimeters. Okay, please press pause, rewind, fast forward. Cylinder, volume of a cylinder, so the area of the base times the height gives us the volume of a cylinder. So a cylinder has a special bottom or base. It's a circle, so the area of a circle is pi r squared times the height. So it's going to look like pi r squared h. Calculate the volume of the cylinder with a radius of 5 and a height of 2. Leave your answers as exact. Talked about exact answers yesterday and approximate answers too. Okay, so step 1, go find the shape on your gold sheet. Step 2, write down the formula. So volume is equal to pi r squared h. Step 3, sub them in, sub those numbers in. We're going to sub in 5 for r and 2 for h. So we get pi, 5, and then h is 2. Okay, I'm missing something. You tell me what I'm missing. I'm missing something. It's not the V. Missing something else. Right, if you guess the square, that's it. So we get pi times 25 times 2. Because 5 times 5, 5 squared is 5 times 5. This is the same thing as pi 5, 5, 2. If you want to write it like that, you're more than welcome to. Right, so here we get pi times 50. Right, and that's going to be our exact value. You can read it like that, or you can read it like 50 pi, but remember we have to put centimeters cubed. In order to determine what it is as an approximate answer, what we do is we have 50, and then we're going to multiply that by pi on our calculator. Go find that button on your calculator. So the calculator. Not just 3.14. So go and find pi on your calculator, click that, and we get 157.0796, and it just keeps on going. Now it says to round to 1 decimal place. So we're going to take this 7 and we're going to round that number up. See you later. To a, well, it's not going to be 0 anymore. What's it going to be? 1 centimeters cubed. All right, and this is what we call an approximate answer. All right, now what would happen to the volume of a cylinder? So let's go draw a cylinder. What would happen to the volume of a cylinder if the height is doubled? So we're going to have 2h and the radius stays the same, so just r. Okay, so the volume is V is equal to pi r squared h. Now instead of just a single h, we're going to write 2h, and r is going to stay the same. So we've got pi r squared 2h now, doubling the h. So instead, let's write this with the coefficient in front. Let's write this with the 2 in front. Hey, and that looks like something that looks like the volume of a cylinder. So what happened to the volume of a cylinder if we double the height? Therefore, double the height means the volume doubles. See how it's the volume times 2? The volume, or it gets 2 times bigger. Alright. Now looking at the volume of a cylinder where the radius is doubled and the height stays the same now. So again, we have another cylinder. The height stays the same, but the radius is doubled, so we're going to have 2r this time. We're going to do the exact same thing, pi r squared h. We're going to put 2 r in for r and just leave this one as h. So it's going to be 2r squared h. See, it's 2r, double the radius, and times its height. Right? And then this is something we did last unit, 2 units ago. We bring that 2 into the expression, because really what's happening here, we have pi 2r, 2 copies of 2r, right? We have 2 copies of 2r. We get 2 squared r squared h, which is 4r squared h. Let's bring that number 4 up to the front, and we get, hey, that's the volume of a cylinder right there. So how many times bigger is it? So therefore, if we double the radius, what happens to the volume? The volume is 4 times bigger, or quadrupled. All right, click the next link for the next video.